Okay, let me do an example now using these transforms. So let's say I have a robot vehicle and it has a sensor mounted on it and it's sitting in the world somewhere, and we observe a point in that sensor coordinate system. We want to know where is the point in world coordinates. So let me just draw the scene here. Okay, so let's say the world is here, and it has its x-axis this way, z-axis is up, and y points in. And the vehicle is sitting here, and its x-axis points forward, its z-axis points down, and of course the y-axis would point toward us. And then we've got a sensor up here whose z-axis points forward, y-axis points down, and the x of course would point toward us. And we'll call that S. And we see a point in the world out here somewhere, call it point P. And let's say that the coordinates of P and S are 0, 4, 10. And let's say that the vehicle, origin of the vehicle in the world is 5, 0, 1. Okay, so I'm using homogeneous coordinates for this point, but just a 3 vector for the translation. And let's say that the sensor origin on the vehicle is a 1, 0, minus 2. Okay, so we want to find, we want to do this. We want to say, if we can construct the transformation from vehicle to world times the transformation matrix from sensor to vehicle times the position of P in sensor, we could get the position of the world. Okay, so let's look at these pieces individually. So the vehicle to world transform, we are going to need the rotation piece of that, and obviously it's just a rotation about the x-axis by 180 degrees, which is a 1, 0, 0, 0, minus 1, 0, 0, 0, minus 1. And the full transformation from vehicle to world will be 1, 0, 0, 0, minus 1, 0, 0, 0, minus 1. And then the translation of vehicle in the world, I said, was a 5, 0, 1. Okay, now the other one from sensor to vehicle is a little trickier. We actually have to do 2 rotations here. So let me go to the next slide. So let's draw the vehicle coordinate system again, which looked like this. And recall that the sensor coordinate system looked like this. So we want to rotate, we want to find the rotation from sensor to vehicle. So that means we start with the sensor aligned with vehicle, and we rotate about the x-axis of the vehicle, the y-axis of the vehicle, and the z-axis of the vehicle until we wind up with the vehicle's coordinate system. So the first step then is rotate about x. So the x-axis of the vehicle. So we are going to rotate 90 degrees about the x-axis, and that's going to put the y-axis of the vehicle pointing down and the z-axis pointing in. Now we rotate about let's see, the y-axis of the vehicle of the vehicle, but we don't want to do that because x-axis is already pointing in the same direction. So let's just rotate. Let's skip that, and we'll rotate about the z-axis of the vehicle. So we're going to rotate about that by 90 degrees, and we're going to get z pointing forward and y pointing down. So this is a 90 degrees, and this is also a 90 degrees. So the final rotation matrix will be this by 90, this is 0, this is 90. So I'm going to get a 0, minus 1, 0, 1, 0, 0, 0, 0, 1 times 1, 0, 0, 0, 0, minus 1, 0, 1, 0. And that gives me a 0, 0, 1, 1, 0, 0, 0, 1, 0. And it's good to, again, check this, make sure we did all this right. If I look at this first column, this should be the unit vector of the sensor in the vehicle. So the unit vector of the sensor, x unit vector, should point in the positive y direction, and it does, as you can see. So it looks like it checks out. So finally, we're going to have the full transformation matrix from sensor to vehicle as this rotation, and the translation was a 1, 0, minus 2. Okay, so let me try to do this in Matlab. Okay, so I'm going to need the transformation from vehicle to world. It's going to be a 1, 0, 0, 5, 0, minus 1, 0, 0, 0, 0, minus 1, 1. And then, of course, the last row is that. The transformation from sensor to vehicle is 0, 0, 1, 1, 1, 0, 0, 0, 0, 1, 0, minus 2. Whoops, screwed that one up. Let's do that again. Zero, 0, 1, 1, 1, 0, 0, 0, 0, 1, 0, minus 2. and then 0, 0, 0, 1. Okay, so the position of the point in the world is the transformation matrix from vehicle to world times transformation from sensor to vehicle times the position of the point in the sensor, which I said was a 0, 4, 10, and then the 1. Okay, so we get that the point in the world is 16, x equals 16, y equals 0, and z equals minus 1, which kind of makes sense from looking at the picture originally.